Welcome back. This is the solution to test 1. Test 1 requires that you practice, that you understand the problems that we have been solving during the course. And this is the first problem that you have encountered in test 1. It's find the antiderivative of 4 secant theta tangent theta dd theta. Find and apply the first fundamental theorem of calculus to find the value of this integral. So secant theta is 1 divided by cosine of theta. So secant theta is the reciprocal of cosine of theta. And the derivative of secant theta is the derivative of 1 divided by cosine of theta. And the derivative of 1 divided by cosine of theta is the derivative of the numerator 0 by the denominator 0. The derivative of the denominator minus the derivative of the denominator. The derivative of the denominator is minus sine of theta, with the minus sign will be plus sine of theta, divided by cosine square of theta, divided by the denominator square. You know that. So this can be written like 1 divided by cosine of theta, sine of theta, divided by cosine of theta, separating the cosine of theta. And this is secant theta tangent theta. As a result, the derivative respect to theta of secant theta is secant theta tangent theta. What we have learned is that any derivative equation takes you to an integral equation. And what it says that the integral equation will say that the integral of secant theta tangent theta dd theta, the integral will be secant theta. The antiderivative of secant theta tangent theta is secant theta. So we do the problem. The integral from minus pi divided by 3 to pi divided by 3 of 4 times secant theta tangent theta is 4 times the integral, and is 4 times secant theta. Secant theta evaluate between minus pi divided by 3 and pi divided by 3. So it will be 4 times secant of pi divided by 3 minus secant of minus pi divided by 3. But secant of pi divided by 3 is 1 divided by cosine of pi divided by 3. You don't need to know that cosine of pi divided by 3 is 1/2. So this will be 1 divided by 1/2, which is 2. And this will be also 1 divided by 1/2, which is also 2. So the difference will be 0. So what you need to realize that cosine of pi divided by third is it has the same value that cosine of minus pi divided by 3, so the integral will be 0. And this means that this function is an odd function. This function is an odd function. So f of theta should be equal f minus theta with minus sign. F of theta should be minus f of minus theta. And the function have a total area between minus pi divided by 3 and pi divided by 3 equals 0. Okay, let's go to the next problem. The next problem give you a differential equation that say that the derivative of h respect to t, h prime of t, the derivative is 8 times t cubed plus 5. And the problem is asking you, who is h of t? What is the function whose derivative is 8t cubed plus 5? Or in other words, what is the antiderivative of 8t cubed plus 5? Okay, so the function that I have to plug in here in a way that the derivative respect to the t, it will be 8t cubed plus 5 is the function 8t4 plus 5t. Or in other words, the antiderivative of 8t cubed plus 5 is 8t4 divided by 4 plus 5t. or 2t4 plus 5t. Okay, so plus c. Okay, now it's a once that you have h of t like 2t4 plus 5t plus c, determine what is c. How you will determine what is c? You will say the problem is saying me that from the whole family of functions that exist, h of 1 is minus 4. So I will plug in this information into this equation, and this will allow me to solve for c. H of 1 equal minus 4. What is h of 1? Is 2 times 1 to the 4 plus 5 times 1 plus c. So 2 times 1 plus 5 times 1 plus c is minus 4. This I will solve for c. So c equal minus 11. And finally, the final solution is that h of t is 2t4 plus 5t plus minus 11, plus c, minus 11. This is the solution. Okay, this following problem is find the average value of the function 4x cubed minus 3x squared on the interval minus 1, 2. So the important thing is that the function is continuous here. I'm not representing this function, 4x cubed minus. I'm saying what is the idea of the average value. The idea of the average value will be here on the y-axis. It will be a value of the function that the area that he will perform, the area, it will be an area of, it will be a value of the function. I will call it like this. I will call it like this, the value of the function whose area will be equal to the area of the function itself. So this line should be a little bit lower to represent the same area. So the average function may be something like this. And now the area even a little bit lower, because the area of the rectangle should be equal to the area under the curve. So the condition that I say to define the average value of the function is that the average value of the function by b minus a, which is the area of the rectangle, the value by b minus a is the area of this rectangle, should be equal to the area under the curve. So what is the value, the average value? Well, the average value will be 1 divided by b minus a by the area under the function, the area that exists under the function. So the question is just to plug in numbers. You plug in numbers, you make the easy integral like this, and you will find the number 2. 2 is the average value. It means that at the level 2 through the y-axis, the area of the rectangle that you construct between minus 1 and 2 is equivalent, is equal to the area under the curve. Okay, let's go to the next problem. The next problem says integrate the function f of x equal to the integral from t equal pi divided by 4 to t equal x of the function secant square t dt. The function secant square of t have an antiderivative. What is the antiderivative of secant square of t? Is tangent of t. So this will be equal tangent of t evaluated between t equal pi divided by 4 and t equal x. So f of x, the function f of x, will be tangent of x minus tan of pi divided by 4. Or in other words, the function will be tan tangent of x minus tangent of pi divided by 4 is 1, minus 1. So this is the function, and the first part of the problem is already done. Let's go to do the second part. The second part says illustrate the second fundamental theorem of calculus by differentiating the result. Okay, let's go to make the result. So it says the derivative respect to the x, part B, of f of x, or the derivative respect to the x of tangent of x minus 1, the derivative should be equal to secant square of x. Wow. Well, we'll do the derivative and we check it. When we do the derivative of tangent of x, the derivative of tangent of x is secant square of x, because it's the derivative respect to the x of tangent of x, which is sine of x divided by cosine of x, and if you do it, it will be 1 divided by cosine square of x, which is secant square of x. So what we have proven is what we have checked, we have not proved. What we have checked is that if you start with f of x equal the integral from a to x of f of t d dt, and you make the derivative of f respect to the x. So you make the derivative respect to the x of f of x, the integral from a to x, the integral from a to x of f of t dt. What you will obtain? You will obtain the integral of the integral evaluate at the function at the point x, f of x, secant square of x. And the problem is done. If you have some doubts, you should check the video about the proof of the second fundamental theorem, and maybe it will be even more clear. So in this problem, we use logarithmic differentiation to find y prime. So we start with y of x, and y of x is a square root of x squared minus 1 divided by x squared plus 1, and we impose that x should be bigger than 1, but I think the condition should be that the absolute value of x should be bigger than 1. We'll see now taking the logarithm function. So if we take the logarithm both sides of the equation, what will happen? The logarithm of y, natural log of y, will be the natural log of the square root of this function. And the square log and the natural log of y, I can place like the natural log of x squared minus 1 divided by x squared plus 1 raised to the power 1/2. And applying a property from the logarithms, I know that the natural log the natural log of a to the x is x by the natural log of a. So it's 1/2 by the natural log of x squared minus 1 divided by x squared plus 1. And now I can do the derivative. What is the derivative of the natural log of y? It's 1 divided by the function by the derivative of the function. And here is what I want to find, the derivative of the function. It will be 1/2 by the function, the derivative of the natural log. The derivative of the natural log is 1 divided by the function. So it will be 1 divided by the function. It will be x squared plus 1 divided by x squared minus 1 by the derivative of the function, the derivative respect to the x of the function. x squared minus 1 divided by x squared plus 1. Okay. Now the derivative of this quotient of these two functions is the derivative of the numerator by the denominator minus the derivative of the denominator multiplied by the numerator divided by the denominator square. If you do it carefully, you will find, let's go to do it, the derivative of the numerator 2x by the denominator minus, let me put parentheses here, minus the numerator by the derivative of the denominator 2x divide by the denominator square, x squared plus 1 square. So this will be equal to 1/2 x squared plus 1 divided by x squared minus 1 that multiply 2x divided by x squared plus 1 minus 2x divided by multiply by x squared minus 1 divided by x squared plus 1 square. And this, sorry, I didn't write the square. And this is, oh, no need, sorry, no need, I already did the x squared plus 1 divided by x squared plus 1 square. This is this. Okay. So what is the derivative of y respect to the x? The derivative of y respect to the x is y by everything, by 1/2 x squared plus 1 divided by x squared minus 1 multiplied by everything here. But what is y? Y is x squared minus 1. Y is x squared minus 1 divided by x squared plus 1 raised to the power 1/2. So let's go to put it here. It's long. The derivative of y respect to the x is x squared minus 1 divided by x squared plus 1 1/2, this is y, by 1/2 by x squared plus 1 divided by x squared minus 1 by the derivative of all these things, that is 2x divided by x squared plus 1 minus 2x x squared minus 1 divided by x squared plus 1 square. And if you reduce a little bit this will be 1/2 square root of x squared minus 1 divided by x squared plus 1 will appear 2x x squared minus 1 x squared minus 1 minus 2x x squared plus 1. Check it that this is the final result. Okay. Remember that I don't correct by the result. I correct by the procedure that you use to solve the problem. So even if you don't have exactly the same result and you did it well, you don't have to worry at all. Next problem says find the indefinite integral of secant tangent x divided by secant x minus 1. This is a substitution problem. So if we name u like secant x minus 1, we know that the derivative of u respect to the x is the derivative of secant of x, which is secant tangent, minus the derivative of 1, which is 0. So ddu is secant x tangent x ddx. Oh, and ddu is sitting down in front of you. This is ddu, and this is u. So the integral is the integral of secant x tan x divided by secant x minus 1 ddx is the integral of 1 divided by u ddu. So the integral of 1 divided by u ddu is natural log of u plus c, but u is secant x. The problem is not solved yet until you write that the solution is natural log of u, natural log of secant x minus 1 plus c. Of course, you can take this function, do the derivative, and you should find the integral. Next problem. Okay, let's go to do this problem. It says find the equation of the tangent line to the graph y equal log base 10 of 2x at the point 5, 1. So find this line. So you have the graph of the log of 2x. The log of 2x is very similar to the log of x. And you have to go to the point x equal 5. You need to find the slope at x equal 5, 1. And you need to find the slope, and later on you need to find the equation of the rectilinear line that passes through the point 5, 1. Okay, let's go to do it. If I have y equal log base 10 of 2x, the definition of log base 10 is that this is equal to the natural log of 2x divided by the natural log of 10. This is the definition. The definition of log base v of x is that is the natural log of x divided by the natural log of b. Okay, so I will do the derivative here to find the slope here. The derivative of the function respect to the x at the point x equal 5 will be, what is the derivative? This is a constant. And the derivative of the natural log of 2x is 1 divided by 2x by the derivative of 2x. The derivative of x is 2. So it will be 1 divided by the natural log of 10 divided by 1 divided by x. Evaluate at the point x equal 5, the derivative will be 1 divided by the natural log of x, 1/5. And this is the slope at x equal 5. The slope is changing as I'm moving, and the slope is changing in a way that every time the slope is decreasing. It's a small slope. Okay, and what is the problem asking me is find the equation of a rectilinear line. The equation of the rectilinear line is y equal y0 plus the slope x minus x0. I know the slope, I know the point x0, y0, which is the point 5, 1, so I can know what is the equation of the rectilinear line. So y of x equal y0, which is 1, plus the slope that is 1 divided by 5 natural log of 10 by x minus x0, x minus 5. And this is the final result for the equation of the tangent line to the graph y equal log base 10 to x. And that's all. Now, this problem says use a right triangles to evaluate the expression of secant arc sine of 4/5. I have to say that all these problems, they are done on the playlist. They form part of your learning activities. you should know how to do it because you have seen how this problem is done. So let me try to do it again. So I have secant of something, y, where y is arc sine of 4/5. So let me write this in a different way. Y is arc sine of 4/5. If y is arc sine of 4/5, if I apply the inverse function of the arc sine, the inverse function of the arc sine is the sine. Sine of y should be equal to the sine of the arc sine of 4/5, or in other words, should be 4/5. So the equation that I will have is that sine of y is 4/5. Now the problem is use right triangles to evaluate the expression secant of arc sine of 4/5. Okay, so first of all I stop here and I say, okay, if sine of y is 4/5, means that this is y, and the sine is the opposite divided by the hypotenuse. So should be this triangle 4/5. And what should be the adjacent? The adjacent side should be a square root of 5 squared minus 4 squared. And what is 5 squared minus 4 squared? Is 3. Okay, and they say the problem is asking me find secant of arc sine of 4/5. In other words, find secant of y, because this is y. And what is secant of y? Secant of y is 1 divided by cosine of y. And what is cosine of y? Y is here, and cosine of y is adjacent divided by hypotenuse. So it will be 1 divided by cosine of y. Adjacent 3 divided by hypotenuse. So the result should be 5/3. So here you can write 5/3. This is the number. Okay, now let's go to solve this problem. This is a substitution problem, and you can find the integral is the definite integral from 1 to 3 of e to the 3x divided by x squared. If you name u like 3 divided by x, v du, the derivative of u respect to the x will be minus 3 divided by x squared ddx. So the derivative will be this one, and v du is sitting down in front of you. d du is minus 3x squared ddx. So it's almost here. It's 1 divided by x squared ddx. So d du divided by 3 with the minus sign is 1 divided by x squared ddx. So it's sitting down in front of you this factor, 1 divided by x squared ddx. So the integral will be the integral from the definite integral from 1 to 3 of the function e to the 3 divided by x divided by x squared ddx will be equal to the integral from 1 to 3 from x equal 1 to x equal 3 of e to the u. Now 1 divided by x squared ddx is minus v du divided by 3. So this integral will be minus 1/3 the integral from x equal 1. But now the limit of integration has changed because u is equal 3 divided by x. So when if x equal 1, u is 3 divided by 1 is 3. If x equal 3, u is equal 1. So now the integral is not from x equal 1 to x equal 3. I have to correct this. The integral is from u equal 3 to u equal 1. And now I can do it. E to the u, du from u equal 3 to u equal 1. So it will be equal minus 1/3. What is the integral of e to the u? E to the u. E to the u is the function. So from u equal 3 to u equal 1. So it will be minus 1/3 that multiply e to the 1 minus e to the 3. So it will be minus 1/3 e that multiply 1 minus e squared. And this is the final result. That can be written to take out the minus sign, so it's 1/3 e that multiply e squared minus 1. I have reversed this minus sign inside, and now this is the integral. Is a positive number or a negative number? Let's go to check. E squared is like more or less 9. 9 minus 1 is 8. 8 by 2 is positive number. It's a positive number. Okay, so the area of the curve is positive area.